In this lesson, we are going to look at how we can work out the equation of a straight line. Let me remind you, straight line on a Cartesian plane generally have the equation of y equals to mx plus c. Let's see how we can work out the actual equation. If you're given a straight line graph with a gradient of 3 and y-intercept 2, what is the equation of the line? Now, we know that the coordinate of the y-intercept is 0, 2 because it was stated here in the question, y-intercept is 2. On this line, y equals to mx plus c, each dot could be represented by coordinates of x, y. And we know that y is related to x by this equation. So, if we actually substitute the information that we have, xy, and the y-intercept, we can also work out the m. Alright? So let's do this. We have xy, and this point here is x is 0, y is 2. So, using the gradient equation, m equals y minus 2, and x minus 0. We also know that the gradient m is 3, which is given. Therefore, this equates 3. X minus 0 is just x. So by manipulating, we know y minus 2 equals to 3x, and the equation of the line is therefore y equals to 3x plus 2. Let's do another example. Find the equation of the line with gradient 2 and the y-intercept 5. Again, we know the coordinate of the y-intercept is 0, 5, and we can substitute this into the gradient equation, which is m equals y minus 5 over x minus 0. This time, we know that the gradient is actually 2, not 3. Therefore, y minus 5 over x minus 0 is equals to 2. Again, by manipulating, we find that the equation of the line is 2x plus y. So, if you actually look at these two examples very carefully, what I have done here is actually look at y equals to mx plus c. We substituted the gradient 2 directly into m, and then the y-intercept of 5 directly into c. It's actually a very straightforward process. Let's have a look at another example. We are asked to find the equation of the line with the gradient 2 and the y-intercept 3. Now, from the previous explanation, we can substitute the gradient of minus 2 as m and y-intercept of 3 as c. So, the equation is therefore y equals to minus 2x plus 3. Alright, as a summary, so if you're given the gradient of the line, m, and the y-intercept, c, we substitute the gradient and the y-intercept straight into the general equation of y equals to mx plus c. It is fairly straightforward. What if we are given 2 points? x1, y1, x2, y2. We know that y equals mx plus c, and since the 2 points are known, we can calculate the gradient of m using the information given by the 2 points. Once we calculated m, the rise over run, we use the information of either this point or that point to calculate c. Best to do it by a couple of examples. Now, this example here, find the equation of a straight line which passes through the point 2, 3, and 4 minus 5. We know mx plus c. Calculate m using this, let's say x1, y1, and this point x2, y2. Now, substituting into the equation for m, we can work out that the gradient is minus 4. So, we can substitute m minus 4 into that equation, and that will give us this. To calculate c, we either use the point 23 or 45. We know that when y is 3, x is 2, or when y is minus 5, x is actually 4. So let's use the first point, 2, 3. If we substitute 2 into minus 4x and y into 3, we actually obtain the following. 3 equals to minus 4 into 2 plus c. Manipulating and rearranging, c therefore equals to 11. And the equation is y equals to minus 4x plus 11. How about if we use 4 and 5? We know that y is actually 4 and minus 5. Y is minus 5 equals to 4 minus 4x times 4 plus c, which is minus 5 equals to minus 16 plus c. Rearranging, we know that c therefore equals to 16 minus 5, which equals to 11. Same results, and therefore the equation is y equals to minus 4x plus 11. Let's try another example. This time, let's find the equation of a straight line which passes through the point 3, 5, minus 3, minus 5, and 1, 8. Again, using the similar way of doing it, y equals to mx plus c, we actually calculate the gradient of m by using this information, which is, let's say, x1, y1, and x2, y2. And we worked out that the gradient is 13 over 4. So y equals to 13 over 4x plus c. Substitute either 3 minus 5 or 1, 8 into this equation. Say we started using 1, 8. We can work out that c is equal to 19 over 4. Let's try using minus 3 minus 5. So y equals to 13 over 4 x plus c. X is minus 3, is 13 over 4, minus 3 plus c, and y is minus 5. Therefore, minus 5 equals to minus 39 over 4 plus c. Manipulating, c equals to 39 over 4 minus 5. Or actually bring it into the same denominator. It's 4. 39 minus 4, 5 is 20. And that gives us 19 over 4. Therefore, the equation is y equals to 13x plus 19 over 4. So, in summary, we can use the information given from 2 points, x1 and x2, to calculate the gradient m. And then we use the information from one of the point to calculate c and derive y equals to mx plus c. Alright, this is the end of the lesson. Thank you.